In this series of videos I'm attempting to repair and restore this HP9845B vintage computer. So far in this series I've stripped the system down into its major sub-assemblies and I've been working my way through them, carrying out repairs as I go, and I got the power supply up and running, found a few faults with that, and then I turned my attention to the two processors. And I've been finding far more faults than I was expecting. I've got the feeling this machine was maybe running too hot because the vents were blocked up. Because a lot of the ICs haven't failed, but they are giving very low outputs. A lot of the buffers and line drivers, for example, are giving very poor output signals. That is borderline with regards to driving the following circuits. For example, I've got some 7404s that are giving an output that's about 50% of what we would normally expect to see. I'll show some of these in future videos. But I've been working my way through sequentially, trying to take a logical approach to get this working, because it's quite a complex machine. So I started off finding a couple of faults with the two hybrid modules. I corrected those, and then I turned my attention to the boot up sequence and attached the logic analyzer and found that the PPU wasn't getting to the startup code, it wasn't jumping to the monitor program, and I found a faulty ROM. So this was the reason it wasn't getting to the boot up, and so I made up a replacement ROM module on a breadboard. These are a bit unusual. They have latches built into the address inputs, and that is needed for this machine. So I put together a circuit based on a 2764 with a couple of latches, plugged that in, programmed the EEPROM with the correct code for this ROM, plugged it in, and the system then started jumping properly to the monitor program. But it still wasn't booting up, and it wasn't getting properly into the monitor. It was jumping to the start of the monitor, and then it was doing strange things, and the code being returned from certain addresses was still wrong. This is all these ROMs are the block 5 code. So the next thing I did was to take out all the ROMs. I've taken all the ROMs out of both of the ROM boards now and tested them, and they all tested good apart from 3. So we had the one we know about. There was a second one that is failing. This has got a bit of an odd failure mode, in that when I put it into the reader and try and verify it against a known good image, it fails the validation, the verification, but it does so right on the last byte. And when I try and read it, it reads successfully but comes up with a verification failure. So for example, if we take this ROM and I read it, when I verify it, it should actually pass verification, because what we're reading the second time should be the same as what we read the first time. So even though it's incorrect as far as what should be in there is concerned, it's consistent. That's not always the case. It depends on the mode of the failure. This one's a bit strange in that it's returning the right values but still coming up with a verification failure. And then sometimes when I try and read it, it's coming up with random values for certain addresses. So I think the problem with this is actually the latch on the address inputs, but either way it's not working properly. So I made a second ROM breadboard that then started returning the correct values to the monitor code. So when I started stepping through it with the logic analyzer, addresses that had previously given wrong instructions were then correct. It still won't boot up, but it is now getting further through the ROM code. While I was testing this board, I also popped out the LPU ROM board, tested those ROMs. I found one ROM, they basically all worked, but I found one ROM that had 2 pins broken off, and so I cleaned those up and soldered them back on. There's an image of the repair here. Refitted those. They weren't being accessed, so the chip enable line for that particular device wasn't being toggled, so we weren't getting to the part of the code that needed it, but it's repaired now, so when we eventually get the machine running and it needs to access that ROM, it should now work. They all read OK, and once I'd repaired that one with the broken pins, that one read OK as well. So as I say, it's still not booting up, and if I look at the quality of the signals on the PPU ROM card, they look extremely poor, but they look poor throughout, and I think that's partly due to the fact we've got it on risers and that we have these two monstrosities plugged into it, which it doesn't like. If I look at the same signals on the LPU ROM card, they look much better. Bear in mind the two cards are identical apart from the position of one jumper and of course the contents of the ROM. So I need to get this plugged back in, but of course I can't do that with these plugged in. So I need to find some solution. These were proof of concept to make sure that the system could return the correct values and that it was definitely a faulty ROM. So what I've done is designed a small module board that will plug in place of each individual ROM. It's based on an EEPROM with a couple of buffers, same size as one of these, and it will plug directly into the board, but it will have up to 8 images. There are 8 ROMs on each of the 2 ROM cards. There are some small jumpers on the module that allow selection of the particular image that's in the EEPROM. So I'm now waiting for those to be delivered, be a week or so. Once they turn up, I'll get some made up and tested, but I can't really progress with the main repair until I do that. The next step is to get this plugged in and start tracing it through some more, but of course I can't do that with this arrangement. So what I'm going to do while I'm waiting is turn my attention to the printer mechanism. Now, it was completely jammed when I first started working on this, but I freed it up so it would at least rotate, and if I put the printer driver board in, it's not plugged in at the moment, but if I plug that in, power it up and press the paper advance key, the printer does turn. So it probably works, but I need to dismantle the mechanism, get it freed up. It makes a horrible screeching noise when I try to rotate it. So what I'll do, I'll plug the card in and let you hear the noise it makes, and then we'll take the printer out and start trying to overhaul it. That's the printer control board plugged in. We'll power the machine up, and I'll now try pressing the paper advance key, and you should be able to hear the horrible noise the printer makes. So I won't do that again. And so we obviously need some attention, so I'm going to take it out, we'll have a look at it, see what needs to be done, and hopefully by the time the modules turn up we'll have a working printer. So looking at the printer mechanism, it's fairly simple. It's a very solidly built aluminium frame, series of rollers, big motor on the back, and then we have the print head and the print head drivers at the front. So the first thing I'm going to do to dismantle this, I've got a feeling this just needs a really good clean. It's really tight, it's really hard to turn. And the first thing I'm going to do is slacken off the belt. For some reason this belt is ridiculously tight. I suspect that might be part of the problem. I don't know why it would be that tight. I don't know if the belt shrunk over time, but it really shouldn't be as tight as that. You can hear it is very, very tight indeed. So I'm going to get the belt out of the way. All I need to do is slacken off the screws that hold the motor to the side cheek. The top one and the bottom rear one are slotted, and we should be able to then just rotate the motor out of the way and get the belt to slide off the pulleys. So I've slackened off the screws, and hopefully we can tilt the motor up, which we can. Okay, well, that's the belt off. She appears to be in good condition, so we won't need to replace that. Okay, this is still very tight. The motor's not too bad, and that's not too bad. So all of it seems fairly free now, apart from the rubber roller, which is not turning very freely at all. So I think that's where the resistance was. Okay, one of the issues in dealing with this is that there are no interconnects on this. We've got the main plug coming in, and then connections go off to the motor, through to the paper sensor on the other side, but the wire goes through a tube and the sensor is too big to go back through that tube. And you can get it apart if you push the little tabs down on the connectors or connector pins. You can withdraw them from the connector. Don't really want to do that, and I'm going to see if I can get the rollers out without doing that. And all I really want to do with this is clean it up, at least initially, and see if it works. If we need to come back in later and carry out repairs, we will. But this first step is really just to get it cleaned up. So I'm going to take this front bar off, get this out of the way, and then we can start trying to separate this the end side cheek a little bit and see if we can get the pulleys out, or the rollers out. There's a little circlip on each end, so once we've removed those, we should be able to withdraw the rollers from the side cheeks. Next thing I'm going to do is take out the black parts, get that out of the way, and then that should give us better access to try and remove the various pulleys. Remove the lower screw from the other side, slackened off the top screw, done the same thing on this side, and we should now be able to withdraw this part of the mechanism. So it should come out in one piece, which it does. It's in good condition, so it just needs a clean. And the next thing we want to do is to try and take out the paper guide. To make sure I don't damage it, I'm going to remove the paper sensor. There's a slotted paper sensor here, and then once I've done that, I should be able to remove this part of the guide. So I've taken the two screws out that hold the paper sensor in place and just ease that out of the way. I've removed the two screws from each side that hold this aluminium guide in place, and we should now be able to withdraw that. Which we can, so that's out of the way. Again, looks to be in good condition, just needs a clean. The next thing I want to take out is this lower guide, and there's just a screw at each side, and then we should be able to withdraw that. I've taken the two screws out of each end that hold this inner plate in position. This can now be dropped out through the bottom of the printer. I also had to remove the pulley off this shaft because it was in the way of the screw, so it's just a circlip, and then you can very gently prise this off. So I'll get this out of the way, and then I've also removed the screw that holds in the end plastic support for the print head itself. And what I can now do is remove the circlips from the end of the shafts, remove the other pulley that's on the top roller, the rubber roller, and then I should be able to pull this cheek far enough forward to be able to withdraw the two rollers. So I'll get that done, and then we're pretty much sorted with this dismantling. I lowered the bottom support out of the bottom of the print mechanism, so got that out of the way, unplugged and removed the print head, withdrew the two rollers. Bearings are really dry, and so it partly explains, I think, why it was so tight. But the rubber roller seems to be in really good condition. It needs cleaning, but it's still got some give, so it's not gone completely hard. You can hopefully hear that it's not a piece of rock like they usually end up. I did decide to disconnect the wires. I want to withdraw this. It is quite dirty, so it does need a good clean. So I removed the wires from the connector. It's just really a case of very carefully easing up the little plastic tab that holds them in place. So I should now be able to pull these all the way through, which I can, so I can remove the sensor. This side cheek will now come completely off. I can take the tube out. So that's out of the way. I can remove the final screw that's holding the motor to the side cheek, and the motor will then detach. And that's the printer dismantled. I will probably end up just popping the cover off this. It's, to get this apart, you take the heatsink off. You can then take the screws out of the back and remove this black cover. But I don't want to do that unless I really need to. So I'm hoping this actually works. I've got no idea. It doesn't look too bad, needs cleaning out, but other than that, it seems to be in good condition. The rest of it just needs a good clean. So we've got obviously the two side cheeks. Bearings don't look too bad. They're a little bit worn. They're not too bad. I'll probably rotate them so that fresh part is in contact with the shaft pressure point. Sensor, I don't know if this works, but again it needs a good clean. I know the motor works because that spun the printer when we tried it. Bearings need lubricating, but it actually feels quite good. There's no excess play in the bearings, but again needs clean. The other parts, it's just really giving them a clean. I'll clean up the rubber roller. Can't see any flat spots. Bearings are very dry at each end, so when I reassemble this I'll use some silicone grease. The other parts, again, just a clean. And the bottom roller again is in good condition, quite nice and soft. This needs to be fairly soft, otherwise the paper will tend to jam up, and this is actually in good condition. Again, the bearing's very dry. Belt's in good condition, and just a few screws, clips and pulleys. So that's the printer dismantled. I'll get these parts cleaned, lubricated, and then we can reassemble this and see if it sounds any better when we try and spin it up. That's all the parts cleaned up. They've all come up very nice. There's a fair amount of wear on some of them, but they've cleaned up well. The rubber roller has come up fine. That did clean up, and it is still kind of rubber. It's not gone hard, so that should be fine. The bottom roller is also fine. There's no problems with that at all. So that's good news. We don't have to mess with that and make up a new roller. And the rest of it seems to have come up very well. It mostly seems to have suffered from dirt getting into it. So these have all been in the ultrasonic bath for about 45 minutes, and they've cleaned up well. I've rinsed them off and dried them, except for the print head, of course. I cleaned that manually. Did a few basic checks, and I can't find anything wrong with it, but we won't know if it's working or not until we try it. The paper sensor was completely clogged up with dust and dirt, and I suspect that's the main issue with this particular printer. The filters were missing off the bottom of the machine. I pointed this out in an earlier video, and in most of this vintage of HP machines the filters should be fitted, but they're not that critical. But in this particular machine they are quite important. It stops dirt and dust getting into the power supply and blocking up the fins in that, but also the fans draw a lot of air directly past the printer, so if it's sucking in dust and dirt, that will go straight into the printer. So because I'll probably forget to include this in a future video, I'll just include it here that I will be replacing the filters in this. So these are the filter frames that came out. There wasn't any filter material in it, but I replaced the filter material on these where I think it's necessary. I don't always do it, but in this particular machine I think it's fairly important to replace them. You can still buy the originals, but they're something like £35 each. So what I use to replace the filters is activated carbon filter material. So this is the sort of thing that you get for something like a cooker hood, extraction hood, and you can buy it in sheets. I get it in sheets that are 1/2 metre by 1 metre square. It's enough for about 50 of the filters. It's 4mm thick. As I say, it's activated charcoal type filter. Very effective. It's kind of semi-active in the way it filters out dirt. It's got about the same porosity as the original filters, so it's got very good airflow, but does a very good job at capturing the dust. The difference is this costs about £3 delivered for an entire sheet, so one of these filters costs something like 10p to renew, so it's well worth doing, very cheap, and this is a much easier, more cost-effective way of doing it than buying the originals, and if anything it's even more effective. But this particular machine really does need the filters in place, so it's well worth replacing that. Okay, so on to reassembly. Where there is bearing movement, and there's only really 4 points in this machine that need it, and that's the end of the two rollers, I'll be using a fairly thin silicone based grease. That's the kind of clear grease you'd use on something like a 3D printer. So to assemble this is fairly straightforward. There are different ways you can do it. I usually start off by fitting the bottom guide to the right hand cheek. So this is the right hand cheek, and I'll bolt this into place, and once that's in place we can start inserting the rollers, and this will give us a kind of support to prevent the thing constantly falling over. I'll also bolt in the motor, and that will again stop it moving around too much. So I'll get these screwed into place and go from there. I've got the lower internal support bolted to the right hand side cheek. I've got the drive motor installed, just one screw, so we can fit the belt, remembering of course that the lower front screw also supports the cable assembly. So the next thing I want to do is fit the second guide, so that's this one, so that goes inside and it attaches with just a couple of screws, and we can also now fit the print head back, and all I'm doing here is attaching everything to the right hand side cheek, and then we'll be able to put the left hand cheek on once we've got all the bits and pieces in place. So I'll get this fitted and we can move on to the next part. So that's the left hand side cheek bolted back on. All I had to do, as I said, is line everything up so the rollers pass through the right bearings, put all the screws back in, and it slotted on quite easily. All I have to do now is put the circlips back on to hold everything in place, to hold the tube in for the sensor wire, hold the rolls in place, and then I can refit the drive belt. Now, one thing I noticed as I reassembled this is I don't think it had been assembled correctly before. The back support for the paper was hanging out and the bottom part wasn't in the right place, and the whole thing seemed to be out of alignment. Now at the moment I have the springs out of the tension bar at the front, but when I took this apart the print head was kind of locked up solid, it didn't move, but it looks like it's supposed to just move back and forth freely against the springs, and it wasn't doing that. It was kind of bound up on these side cheeks. Also, the rollers now spin much more freely. There's no resistance to these at all, either one. They both spin around nice and freely. So the next thing, as I say, is to get the circlips fitted, and then it's just putting the drive belt and sensor back in. That's the belt refitted. I've retensioned it. It's nowhere near as tight as it was, but it's still plenty tight enough. And I've also refitted the paper sensor, so that's now back in place. And what I'll do now is try putting some paper into it. It's all gone together nicely. It moves the way it should do. The paper tension and also the pressure of the print head seems about right, and it spins freely. So before it was very tight, it was very hard to turn. Now it's quite free, and no, I don't have any parts left over, so that's a good sign. So next thing, I'll get some paper loaded up and we'll see if it manages to feed it through. The paper loaded up without any problems. This is a bit too wide for this printer. It's fax paper. It's thermal paper, so it will work in this printer. And again, it rotates nice and freely, so paper feed seems fine. It all seems to do what it's supposed to. So I'll get this bolted back into the machine and we'll see if it now drives a bit more quietly than it did before. I've got the printer mechanism bolted back into the machine, so we'll power it up and see if it will still drive. It won't print, of course, we don't have the system running, but the paper feed should still work. then it should have stopped making that horrible screeching noise. Well, nothing's gone bang, so that's a good start. So let's try driving the paper out. And that does sound a lot better. It's nice and quiet. Button sticks. A lot of the keys stick, so I'll need to free those up, but it actually still seems to do what it's supposed to. Like I said, it's not going to print anything because the processors aren't running. In fact, the ROM card for the PPU is not even plugged in. So the next phase of repairing this really now is to wait for the ROM modules to turn up, so we can get them, I'll get a couple assembled, see if they actually work, and so that we can then start progressing the fault finding. Can't really do much now until I can plug the ROM card in and get the system to at least start to try and boot up. And once we get to that point, we can start tracing the code through and seeing where it's falling over and where it's failing to progress. So it'll be interesting to see what we find once we get the ROM modules plugged in, but hopefully we can make some more progress.